0.61 prove that ABCD is a parallelogram. Let us deal with these sides first. This pair of sides, AD and BC. Okay, first things first. AD is parallel to BC. It's given there. Now let us deal with the distances. Let's find the distance of AD and the distance of BC. They should be equal. Let's go ahead and find the distances. Let's start with the distance of AD. We just substitute, guys. We just substitute immediately. We take our A's as our 2's. So x2 is minus 2 minus x1. The coordinates of D are minus 8 and minus 6. X1 is minus 8. We squared it plus. Y2 is 2 minus y1 is minus 6 squared. Can you guys punch all of this into a calculator and tell me the answer immediately? Because distance, this is a 6, guys. Yes, 10 units. So therefore, AD is 10. So now let's find BC. It should also be equal to 10. Distance of BC, we substitute it immediately. Let's take this as our 2's and this as our 1's. Okay, so my x2 is 6 minus x1 is 0 squared plus y2 is 5 minus y1 is 3 minus 3, sorry. Punch straight into a calculator and tell me the answer. I'm waiting, patiently waiting. Yes, it gives an answer of 10. So now you have then proven that AD is also equal to BC. So you've done two things. You've proven that the two sides are parallel, also equal. So you're done with this pair of sides. Now let's deal with this one, with this pair. Now let's deal with this other pair of sides. That is this side and that side over there. Sharp. Let's start with gradients, right? The gradient of DC, this line here, the gradient of DC equals 3 over 8. How do we know that? We got it from here, ne? If DC is that, so the gradient is there, 3 over 8. Now we're gonna find the gradient of A, B, and just see if it also gives us 3 over 8. Let's go. The gradient of, let's use a different color. AB equals, let's substitute. Let's take this as our 2's and these as our 1's. Our y2 is 5 minus our y1 is 2. Our x2 is 6 minus our x1 is minus 2. This gives us an answer of 3 over 8. So therefore, DC, which is this side, is parallel to AB. Okay? Sharp. Then the next thing, you're going to check the distances now. You're going to find the distance of AB and distance of DC, and they should also be equal. If they're equal, then you can safely conclude that this whole thing is a parallelogram. So let's find the distance of DC. Different color. Black. Distance of DC. We substitute DC. Let's take this is our 2's and this is our 1's. My x1 is minus 8 minus x2 is 0. x1 is 0 squared plus my y2 is minus 6 minus my y1 is minus 3 squared. Therefore, the distance of DC equals, what's the distance of DC? Did I substitute it correctly? X1, X2, X2, ne? X1, okay. Yeah, I substituted correct. Oh, no, no, no. I think I didn't substitute correct, man. I didn't substitute correct. So I'm dealing with DC, sorry, distance of DC. My X1, X2, sorry. I'm taking this as my 2's and these as my 1's. Okay, I didn't substitute correctly. These are my 2's, my 1's. Okay, X2 will be minus 8 minus X1 is 0 squared plus Y2 is minus 6 minus Y1, sorry, it's minus 3 squared. Yes. Sorry about that, guys. I think I did it right now. That's correct. What did you guys get? Did you get root 73? All right, then let's look for the distance of now of AB. You can call it AB if you like. Distance of AB or AB is fine. A, B, 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 B. Let's take this as our 2's and this is our 1's. Whichever order doesn't matter. These are 2's, this one. So this is our y x2 is minus 2. X1 is 6 squared plus y2 is 2 minus y1 is 5. This gives us an answer of how much? 73. So therefore, A, B, C, D is a parallelogram. Why? Because we start from the beginning, because AD is parallel to BC and AD is also equal to BC. AD is parallel to BC and also they're equal. Okay, and on top of that, we've proven that DC is parallel to AB and they're equal as well. Sharp. That's you having proven that that's a parallelogram. The last question says calculate the coordinates of M. M is this, ne? M is where the two diagonals meet of the parallelogram. What's a diagonal? This is a diagonal. This is a diagonal of a parallelogram. This from A to D there. This is also another diagonal. This is the midpoint of each of the lines. This is the midpoint of that AD, also the midpoint of BC. So if you're looking for the value of M here, having been told or having confirmed that this is a parallelogram, you know this is just the midpoint of A and C. Yeah, so that's going to be your homework. The midpoint of A and C. You're going to use the midpoint formula. I'm not going to show you. You must find it. Thank you so much. I'm going to share with you the